Top 20 Google Cloud Solution Architect Interview Questions and Answers. Ready to ace your Google Cloud Solution Architect interview? Discover the top 20 most important questions and expert answers that will boost your confidence and land you the job. Whether you're a beginner or seasoned pro, this comprehensive guide is your key to mastering Google Cloud interviews. 1. What excites you about working as a Google Cloud Solution Architect? Working as a Google Cloud Solution Architect excites me because it combines deep technical knowledge with strategic thinking to drive real business transformation. GCP's cutting-edge tools, like BigQuery, Anthos, and Vertex AI, enable the creation of innovative, scalable, and secure solutions. I find great satisfaction in helping organizations modernize infrastructure, enhance performance, and optimize costs through tailored cloud architectures. The collaborative nature of this role, involving cross-functional teams and customers, keeps the work dynamic and rewarding. I'm particularly inspired by the rapid pace of cloud innovation and Google's leadership in AI and sustainability. As a solution architect, I thrive on solving complex problems and translating customer needs into actionable designs that deliver tangible value. I'm also driven by the opportunity to mentor others and contribute to cloud best practices. GCP's open ecosystem and culture of continuous learning make it an ideal platform to grow technically while delivering impactful solutions. 2. Describe a challenging cloud architecture project you led. What was your approach? One challenging project involved migrating a large enterprise's legacy on-premises infrastructure to Google Cloud while minimizing downtime and ensuring security compliance. The client had multiple interconnected applications with complex dependencies and stringent SLAs. My approach began with a thorough assessment of their current environment, identifying workloads suited for lift and shift versus re-architecting. I designed a phased migration plan using Google Cloud's Migrate for Compute Engine combined with containerization for modern apps. To maintain security, I implemented IAM roles with the principle of least privilege and integrated VPC service controls. Automation via infrastructure as code, Terraform, ensured repeatability and consistency. For high availability, I leveraged regional managed instance groups and Cloud SQL with replication. Communication was key, so I coordinated with application owners and stakeholders regularly. Post-migration, I set up monitoring with cloud monitoring and cloud logging to proactively manage performance and security. The project succeeded with zero downtime and improved scalability. 3. How do you balance cost, performance, and scalability in your solutions? Balancing cost, performance, and scalability requires a deep understanding of business goals and technical requirements. I start by analyzing workload patterns to choose appropriate GCP resources, like selecting preemptible VMs or auto-scaling managed instance groups for cost efficiency without sacrificing performance. For performance, I leverage caching with Cloud CDN and choose the right database services, such as Cloud Spanner for globally scalable, high-performance needs or Cloud SQL for transactional workloads. Scalability is ensured by designing stateless applications with Kubernetes Engine or App Engine, enabling seamless scaling based on demand. I also implement cost monitoring using GCP's cost management tools, setting budgets and alerts to avoid overruns. Continuous performance testing and optimization are part of the process, including resizing resources or tuning SQL queries. This balanced approach helps deliver resilient solutions that meet SLAs while optimizing cloud spend. 4. How do you stay updated with evolving GCP services? Staying updated with Google Cloud Platform's rapidly evolving services is crucial as a solution architect. I regularly follow Google Cloud's official blog and release notes to track new features and service updates. Participating in Google Cloud webinars, conferences like Google Cloud Next, and online training platforms such as Coursera helps deepen my practical knowledge. I am active in GCP communities and forums like Stack Overflow, Reddit, and Google Cloud Community, which offer real-world insights and problem-solving discussions. Hands-on practice with sandbox environments and building small projects also solidifies my understanding of new tools. Additionally, I pursue certifications and renew them periodically to ensure I'm aligned with best practices. Staying connected with peers and networking with industry experts further enhances my awareness of emerging trends and innovative use cases in GCP. 5. How would you design a high-availability architecture on Google Cloud? Designing a high-availability HA architecture on Google Cloud involves building redundancy, fault tolerance, and failover mechanisms. I would start by deploying resources across multiple zones within a region to protect against zonal failures. For critical applications, I recommend a multi-region approach to withstand regional outages, using services like Cloud Spanner or Bigtable, which provide global replication. Load balancing with Google Cloud Load Balancer distributes traffic across healthy instances and zones automatically. Data redundancy is ensured with managed database replicas and multi-regional storage buckets. I would use health checks and auto-healing features in managed instance groups to maintain application uptime. Network design would incorporate redundant VPNs or interconnects for hybrid setups. Monitoring and alerting via cloud monitoring ensures quick incident response. Lastly, implementing infrastructure as code enables consistent deployment of HA resources and easy recovery in disaster scenarios. 6. Explain the difference between Google Compute Engine and Google Kubernetes Engine. Google Compute Engine, GCE, provides virtual machines, VMs, that give you full control over operating systems and installed software, ideal for applications needing specific OS-level customization or legacy workloads. It's infrastructure as a service, IaaS, and offers scalable, on-demand VMs. In contrast, Google Kubernetes Engine, GKE, is a managed Kubernetes service for orchestrating containerized applications. GKE abstracts infrastructure management, automating deployment, scaling, and operations of containers. It suits microservices architectures and cloud-native apps that require rapid scaling and continuous deployment. While GCE requires manual scaling and management, GKE leverages Kubernetes declarative configuration and built-in features like self-healing and load balancing. Choosing between them depends on the workload. GCE for more traditional or stateful apps, and GKE for containerized, distributed systems benefiting from Kubernetes orchestration. 7. What are the key components of Google Cloud IAM and how do you secure access? Google Cloud IAM, Identity and Access Management, controls who can do what on GCP resources. Its key components include identities, users, groups, service accounts, roles, predefined, custom, or basic, and policies that bind roles to identities. Roles define permissions, following the principle of least privilege, granting only necessary access to reduce risk. To secure access, I enforce strong authentication with multi-factor authentication, MFA, use service accounts for automated processes, and regularly audit IAM policies for unused permissions or overly broad access. I implement resource hierarchy best practices, using organizations, folders, and projects to apply consistent access control. Additionally, I leverage Google Cloud Security Command Center and access transparency logs to monitor and detect suspicious activity. This layered approach ensures secure, manageable, and compliant access control across the cloud environment. 8. How does VPC peering work in GCP? When would you use it? VPC peering in Google Cloud allows private, direct connectivity between two virtual private cloud networks, enabling resources in each VPC to communicate securely using internal IP addresses without traversing the public internet. Peering is non-transitive, meaning each pair requires direct peering. It supports workloads needing low latency and high bandwidth communication across different projects or organizations while maintaining isolation. I would use VPC peering when two teams or business units need to share services securely without exposing traffic externally, or to connect separate environments like dev and prod. Compared to VPN or cloud interconnect, VPC peering is simpler to set up, has no bandwidth limits, and provides better performance within GCP. It's ideal when you want to maintain network segmentation but enable seamless resource sharing. 9. What's the difference between a zonal, regional, and global resource in GCP? In Google Cloud, resources are categorized by their scope: zonal, regional, or global. Zonal resources exist within a single zone, which is an isolated location within a region, for example, a compute engine VM instance. These resources are susceptible to zone-specific failures, so you often deploy multiple instances across zones for redundancy. Regional resources span multiple zones within a region, providing higher availability and resilience. Cloud SQL instances and regional managed instance groups are examples. They automatically replicate data across zones to avoid single points of failure. Global resources operate across all regions worldwide, such as Cloud DNS, global load balancers, and IAM policies, offering a unified interface and broad accessibility. Understanding this distinction helps architects design fault-tolerant and scalable systems by choosing the right scope based on availability and latency needs. 10. When would you choose Cloud SQL over BigQuery? I would choose Cloud SQL when the workload requires a managed relational database with support for transactional consistency, complex queries, and row-level operations typical of OLTP, online transaction processing systems. Cloud SQL is ideal for applications needing MySQL, PostgreSQL, or SQL Server databases that require ACID compliance, such as e-commerce platforms, CRM systems, or ERP applications. It supports real-time data modifications and integrations with legacy applications. In contrast, BigQuery is a serverless, highly scalable data warehouse optimized for analytical workloads and large-scale data processing, OLAP. BigQuery excels at running complex queries over massive datasets for reporting and business intelligence but is not suited for transactional workloads. So, for operational databases with frequent inserts, updates, and deletes, Cloud SQL is the right choice, while BigQuery is preferred for analytics and big data queries. 11. How do you handle data residency and compliance in GCP? Handling data residency and compliance in GCP starts with understanding regulatory requirements relevant to the client's industry and region, such as GDPR, HIPAA, or CCPA. I select appropriate GCP regions to ensure data is stored within mandated geographic boundaries. Google Cloud offers region and multi-region options, allowing control over data locality. I leverage features like customer-managed encryption keys, CMEK, to maintain control over data encryption. Additionally, I use tools like Cloud DLP, data loss prevention, to discover and protect sensitive data. Compliance certifications maintained by Google Cloud, such as ISO, SOC, and FedRAMP, provide assurance. I also implement strict IAM policies and audit logging to track access and changes. For cross-border data transfer, I ensure encryption in transit and follow legal frameworks. This comprehensive approach helps clients meet compliance while leveraging GCP's global infrastructure. 12. What are the storage options in GCP and how do you decide among them? Google Cloud offers diverse storage options to suit different use cases. Cloud storage is an object storage service ideal for unstructured data like backups, media, and archives. It provides multiple classes, standard, nearline, coldline, and archive, each balancing cost and access frequency. Cloud SQL and Cloud Spanner offer managed relational databases for transactional workloads with differing scale and consistency models. BigQuery is used for large-scale analytical data storage and querying. FileStore provides managed file storage for applications needing a PESIX-compliant file system. Deciding factors include data structure, access patterns, performance, availability, and cost. For example, choose Cloud Storage for scalable object data, Cloud SQL for relational databases, and BigQuery for data analytics. Understanding workload requirements drives the optimal storage choice. 13. How do you secure data in transit and at rest in GCP? Securing data both in transit and at rest is critical in Google Cloud. For data in transit, I ensure all communications use encrypted channels such as TLS, transport layer security, by default, whether between services inside GCP or between clients and cloud resources. GCP services enforce HTTPS and support mutual TLS for service-to-service authentication. For data at rest, Google Cloud automatically encrypts data using AES 256 encryption. To strengthen security, I utilize customer-managed encryption keys, CMEK, or customer-supplied encryption keys, CSEK, for full control over encryption keys. Additionally, I configure IAM policies to restrict access and audit logs to monitor any unauthorized access. Regular vulnerability assessments and data classification help tailor security controls. Combining encryption, access control, and continuous monitoring ensures data remains secure throughout its lifecycle in GCP. 14. Explain how firewall rules work in GCP. In Google Cloud, firewall rules control incoming and outgoing traffic to virtual machine instances based on specified configurations. They are stateful, meaning return traffic is automatically allowed for established connections. Firewall rules are applied at the VPC network level, not the instance level, and consist of parameters like direction, ingress or egress, priority, source/destination IP ranges, protocols, and ports. Rules can either allow or deny traffic. The priority determines the order in which rules are evaluated. The lower the number, the higher the priority. When multiple rules apply, the one with the highest priority takes effect. By default, Google Cloud blocks all incoming traffic except allowed ports. Properly designed firewall rules enable secure access control by limiting exposure and preventing unauthorized traffic, ensuring only trusted communication flows between resources. 15. Describe how you'd set up a secure hybrid cloud architecture. Setting up a secure hybrid cloud architecture involves integrating on-premises infrastructure with Google Cloud while maintaining security and compliance. I start by establishing secure network connectivity using VPN or dedicated interconnect, ensuring encrypted communication. Network segmentation is applied through VPCs and firewall rules to isolate workloads. Identity and access management is unified using Google Cloud IAM combined with on-premises Active Directory or LDAP via Cloud Identity or Beyond Corp Enterprise. Data encryption is enforced both in transit and at rest, using Google-managed or customer-managed encryption keys. Monitoring and logging are centralized with Cloud Monitoring and Security Command Center to detect anomalies. I also leverage tools like Anthos for consistent policy enforcement and workload management across environments. This approach ensures secure, scalable, and manageable hybrid deployments that meet business and regulatory needs. 16. What is infrastructure as code, IAC, and how do you implement it in GCP? Infrastructure as code, IAC, is the practice of managing and provisioning cloud infrastructure through machine-readable configuration files instead of manual processes. It ensures consistency, repeatability, and version control of infrastructure deployments. In GCP, IAC is typically implemented using tools like Terraform or Google Cloud Deployment Manager. Terraform is widely used for its multi-cloud capabilities, allowing you to define resources in HashiCorp Configuration Language, HCL, and automate deployments via the CLI or CI/CD pipelines. Deployment Manager uses YAML or Jinja templates to define GCP resources declaratively. IAC enables automated provisioning of networks, compute instances, storage, and other services, reducing human error and speeding up deployments. Integration with CI/CD pipelines facilitates automated testing and updates, supporting agile cloud infrastructure management. 17. Describe a CI/CD pipeline you'd build using GCP services. A CI/CD pipeline on GCP automates code integration, testing, and deployment for faster, reliable software delivery. I'd use cloud source repositories or GitHub for source code hosting. When code is pushed, Cloud Build triggers automated build and test steps using custom build configs. Unit, integration, and security tests run automatically, ensuring quality. On successful tests, Cloud Build deploys the artifact to environments like Google Kubernetes Engine, Geek, for containerized apps, or App Engine for serverless. Deployment can be staged with Cloud Run or use Canary/Blue-Green strategies to minimize downtime. Monitoring and alerts are integrated via Cloud Monitoring and error reporting for early issue detection. The pipeline is defined as code, versioned, and easily reproducible, supporting continuous improvement and collaboration. 18. What tools do you use for monitoring and logging in Google Cloud? In Google Cloud, I primarily use Cloud Monitoring and Cloud Logging to gain visibility into system performance and troubleshoot issues. Cloud Monitoring collects metrics, sets up dashboards, and configures alerts based on thresholds for resources like Compute Engine, GKE, and Cloud SQL. It integrates with Prometheus for custom metrics and supports uptime checks and incident response automation. Cloud logging captures and stores logs from applications and GCP services, allowing powerful querying, filtering, and exporting to BigQuery for analysis. I also leverage error reporting to identify and track application errors in real time. These tools provide a comprehensive observability stack that helps ensure reliability, optimize performance, and accelerate root cause analysis in Google Cloud environments. 19. A client wants to migrate a legacy monolith to GCP. Migrating a legacy monolithic application to GCP starts with assessing the application architecture, dependencies, and data. I'd evaluate whether to perform a lift and shift migration using tools like Migrate for Compute Engine or refactor parts of the app to leverage cloud-native services such as GKE or Cloud Run. Breaking the monolith into microservices may improve scalability and maintainability but requires careful planning. Data migration involves selecting suitable database services and ensuring consistency. I design the migration in phases to minimize downtime, including setting up hybrid connectivity for data sync. Automation through infrastructure as code ensures repeatable environments. Post-migration, I'd optimize cloud resources, implement monitoring, and validate performance and security. Engaging stakeholders throughout ensures alignment with business goals and smooth transition. 20. How would you design a multi-region failover strategy for a critical web app? Designing a multi-region failover strategy involves deploying the application across multiple GCP regions to ensure high availability and disaster recovery. I'd use global HTTPS load balancing to distribute user traffic intelligently, directing requests to the closest healthy region. Data replication is crucial, so I'd select databases like Cloud Spanner or Bigtable that support multi-region replication with strong consistency. For stateful components, synchronization mechanisms or session replication would be implemented. Health checks monitor regional availability, triggering automatic failover to backup regions when failures occur. Infrastructure as code ensures consistent environments across regions. DNS-TTL settings are optimized for fast propagation during failover. This design minimizes downtime, maintains user experience, and meets stringent SLA requirements. Thank you for exploring the top 20 Google Cloud Solution Architect interview questions and answers. Use these insights to sharpen your skills and confidently tackle your next interview. Keep learning, stay prepared, and you'll be well on your way to success. Good luck with your journey.